Hello, colleagues. Thanks for joining me for this brief walkthrough of my final project on the 29. My project was an integrated query visualization system of NASA's satellite imagery data. Little fun fact, do you know that there's a satellite flying across our vision field if you look up into the sky? In just about every 15 minutes, there's truly a myriad of data generated by those satellites every second. And among them, the data generated by NASA's Moderate Resolution Imaging Spectral Radiometer, also known as MODIS, have been widely utilized by climate and environmental scientists to tackle important questions like climate change and food security. Despite being such a rich asset for the research community, sometimes it could be a big headache also to work with such a myriad of data for the scientists. For one, querying MODIS database is actually not that easy. It requires a lot of idiosyncratic syntax. It likes to date certain ways. It likes you to provide padding around the space frame you're looking at. So for a lot of scientists, getting up to speed with that could be very time consuming. And also by nature of satellite data, it's never as consistent across time and space as we want it to be. So sometimes it can make a quick overview of data quality, data availability at a certain time and space a very challenging task. And as we know that research interests can change in terms of its space, its location, and also in terms of its time frame. Sometimes that require repeating using the same data set. And we know that NASA puts a limit on the bandwidth you can use to access their data. So if you're not managing that carefully, then repetitive downloading and compiling could be very time consuming. So in face of those challenges, I devised these three strategies. First one, cached data set. I put cached in quotes because we're not really storing all that data in our memory. And instead, we're trying to create a efficient file system so that the data is organized in an efficient fashion, either on your local drive or on the research cluster, so that you can access them easily, other than having to query and then request the data from NASA all the time. And also, this pipeline includes a customized data file manager and login system that allows you to track the reading and writing of all the data you've queried and keep a track of what data is available locally or on your research cluster, what data has to be requested from the server again. And also, lastly, I provide a quick visualization feature of some of the simple descriptive statistics, so that you can have a brief understanding of how the data look before you jump into the hardcore legwork of research. So a little bit about a cached data set. The meat of this is really just this file system. So for now, I'm prefixing everything with this tile tag. It's called tile because I think MODIS or NASA has this tradition of naming this particular space and time frame as a tile in their data build. And so it's called a tile. Every file is prefixed with a tile tag. And then right now, the real data is pickled away here in this object. And then I'm also including a metadata JSON file to track information such as the number of rows and number of columns for each of the imageries that we downloaded. And also, apparently, we also need a log JSON file to track all the previous queries we've run, so that we have an understanding of what's available locally or on the research cluster. So a peek into the data log object. Pretty much as what you would expect. It has initiation and creating and adding new entry features. All that is really just so that we're equipped to track each of the queries we're making when we're actually making requests from data manager. Speaking of data manager object, an overview of that is it's an object to translate query attributes to URLs readable directly for Modest server, and it's also managing all the loading and the downloading work, either from your local file or from the server. And it's also managing the file system by creating that somewhat salted tag that we talked about earlier, the tile tag, so that each of the queries that's previously done would be tracked in the log file, and all the data are managed in the traceable fashion. So a peek into the data manager object. I can get a little bit messy here, but also, as you would anticipate, initiation is really just tracking information about the query we're making, where we're storing the data. And also, there is another method to identify, it reads from the log and it identifies which are the new requests we need to make from the server, and which are the data queries we can directly load from our local drive or from our research cluster. And then thirdly, there is this tile tag property that uniquely identifies each of the queries associated with a data manager, as mentioned earlier. And I'm doing all the actual data build and querying in a separate object that directly inherits from the data manager. That code is a little bit bulky and still in development, so I'll skip that for now. In terms of visualization part, it's very straightforward. I was just using Matplotlib to visualize spatial distribution of the output of a user-defined summarization function. And I think the best way to demonstrate that is actually just using a plot. So speaking of that, let's go over some demos of outputs that I have so far. So this is the query dictionary that would feed to that data manager object. Oh, pardon me for this typo here. The prod sequence is a identifier of a specific data product you're querying from Massa's Modest database. And this one, it's identifying NDVI, it's an index for vegetation. And then the band is the particular band you're trying to read from the data from that particular sensor on the satellite. I think it is as a sub-attribute of the data product. And latitude and longitude information, intuitively identifies the location of research interest. And then there is a start date and end date. And this is in a format that NASA, I guess, they really like. It's sort of like the yearly Julian date prefixed by letter A. This is saying we're interested in looking at dates from the second day in 2019 to the 50th day in 2019. And this A, B, and LR, these are space padding around this location. So this is saying going above and below 50 kilometers and left and right 50 kilometers, pardon me, in my sort of like a spatial view field. So if we feed that into the data manager object and run the pipeline gives us this output. When I was running this, I didn't create a log file. So reasonably, the pipeline is warning us that we don't have a log here yet. Everything is going to be requested from the server. And it correctly identified that we have to download 12 Modest queries from the server, and took it just about under 10 seconds. Notice that we're downloading 12 queries other than however many days here are. Because like I said, the data is not consistent across time, meaning that it's not available every day. So you have to smartly pick out, which are the days that have available data and get that data from the server. And after doing all that, we're able to create this simple plot. This is, I believe, the mean value of, across all these days. At this location with the space padding. this is the very intuitive way for researchers to understand, okay, here are some high points. The background level is, below 50. And then if we were to run the same query again, the pipeline correctly identifies that all the 12 modest queries have been cached, and it's just going to load that from my local drive or from my research cluster, and it's not downloading anything from the server, which would significantly reduce the time that it requires to compile that data set. Yeah, it's providing the same overview plot as we've seen with the server downloading workflow. What if we want to change the query date range? So here you notice that I changed the starting date and ending date. There is a little bit of overlap, but not completely distinct from each other. So when I run that through the pipeline knows that it needs to download 5 more queries from the server, and it's loading another 5 directly from the cache. It's taking about 23 seconds. I'm not sure why it seems to be taking longer. It could be related to the server bandwidth at that moment of query. That needs to be further investigated. Speaking of the next steps, I'm interested in looking into if I can use Parquet to optimize my data storage. Currently, I already have a data file, and it's right now essentially a pickled NumPy array. I'm also having a data file stored separately as a JSON file. I'm thinking maybe there is a more optimized way to just directly use Parquet to integrate those 2 files into a Parquet object. Also, I would be spending some time looking into the scalability of the Common Work framework. And then apparently if we can use Parquet to streamline the data storage process, that can benefit the scalability of the framework a lot. But I'm hopeful that this is the pipeline we can leverage so that the researchers would have quick and easier access, at least if they just need a quick overview of the availability and the means and access of the data they're interested in. So yeah, with that, I would appreciate any feedbacks, and thank you so much for taking the time. And stay well.